All right, welcome back. So let's see if we can get this bonus unit, unit one done, and then we'll have a full week to get unit two done. All right, so what is function calling? Function calling is a way for an LLM to take actions on its environment. It was first introduced in GPT-4 and was later reproduced in other models. Just like the tools of an agent, function calling gives the model the capacity to take an action on its environment. However, the function calling capacity is learned by the model and relies less on prompting than other agents' techniques. During Unit 1, the agent didn't learn to use tools. We just provided the list, and we relied on the fact that the model was able to generalize on defining a plan using these tools. So yeah, that was one thing that kind of left me scratching my head from Unit 1 is, okay, we wrote the tool, but how does it actually know to use the tool? So the model was able to generalize on defining a plan that involved using the tool. While here, so another way to do it is, and we're going to do it here, is using function calling. So while here with function calling, the agent is fine-tuned, trained to use tools. How does the model learn to take an action? In Unit 1, we explored the general workflow of an agent. Once the user has given some tools to the agent and prompted it with a query, the model will cycle through number one, think, what actions do I need to to take in order to fulfill the objective? Number two, act, format the action with the correct parameter and stop the generation. Number three, observe, get back the result from the execution. In a typical conversation with a model through an API, the conversation will alternate between user and assistant messages like this. Conversation is going to be a list with three elements in the list, and each element is going to be a dictionary with the keys role and content, and this is, yeah. So there you go. Function calling brings new roles to the conversation. So before, where we had the role of user and assistant, we're going to have a new role. So it's going to bring two new roles to the conversation. The first new role it will bring is one new role for an action. The second one will be one new role for an observation. If we take the Mistral API as an example, it would look like this. Okay, so now we have two new roles to play with. So um, in our conversation before, we only had three elements with two roles. So the first part of the conversation came from the user and said, I need help with my order. Then from the assistant, it says, I'd be happy to help. Could you provide your order number? And then the user again gives the order number. But now we can make that more advanced. The first message comes from the user. What's the status of my transaction T001? Now the assistant can call a function. So now we see we've got the same role, assistant, but now we're calling a function named retrieve payment status, and we're plugging in the order number. So now we've got a new role, so the tool. So now we can interact with, now the tool can be told to do things as well. So now within this, we get the content that it produces. So now the assistant says, your transaction has been successfully paid, because we can see the status here is paid. So we can tell um, the function that was called the tool to look at the status and include that, and then use that for the response from the assistant. But you said there's a new role for function calls. Yes and no. In this case, And in a lot of other APIs, the model formats the action as an assistant message. The chat template will then represent this as special tokens for function calling. So available tools, start the list of available tools. Uh, yep, so end, so this is just like regular HTML syntax, and the list of available tools. Tool calls, make a call to a tool. For example, take an action. Tool underscore results, observe the result of the action, and then the end tag syntax, so end of the observation. For example, the model can decode again. It can go on to do something else. We'll talk again about function calling in this course, but if you want a deeper dive, you can check out this excellent document section. So this is on Mistral. So there is a video here. If it's a short video, I might watch it. Now that we've learned what function calling is and how it works, let's add some function calling capabilities to a model that does not have these capabilities yet. Google Gemma-2-2b-IT by appending some new special tokens to the model. To be able to do that, we need to first understand fine-tuning and uh, I think this is low ranking adaptation. So next section, let's fine tune your model for function calling. Yeah, low rank adaptation. So there you go, short section. Let's see if this video is 6 minutes. Yeah, so let's do the video, and then that'll be it. Just move on from that.
Hi, this is Sophia Yang from Mistral AI. In this video, we'll talk about how to do function calling with Mistral AI with 4 simple steps. Function calling allows Mistral models to connect to external tools like user-defined functions, external APIs, and other tools we may include in the future. In this video, we'll show you a very simple example of how to answer payment-related questions using tools we define. At a glance, there are 4 steps involved with function calling. Step 1 is for user to specify tools and query. Users can define whatever tools they like. For example, a payment status tracking tool and a payment date tracking tool. Users also need to provide a query, for example, what is the status of my payment? Then we pass both the tools and the user query to Mistral model. Step 2 is for our model to generate function arguments. Based on the user query, our model will be able to figure out that we should use the tool payment status with the function parameter transaction ID equals T1001. Now we know which function to run and the parameter for the function. Users can execute the function to get the results. For example, the status of this payment is paid. Then our model takes all the previous conversations and generates a final answer. According to the information available, your transaction with ID T1001 has been paid. Is there anything else I can assist you with? Okay, hopefully now you have a good understanding of how function calling works. Let's take a look at this notebook together. Before we get started, we need to install all the needed packages. Let's first assume we have a data frame of payment transactions. Let's create this pandas data frame. The idea is that when users ask questions about this data frame, they can use certain tools to extract information from this data. Step 1 of function calling is for users to specify tools and query. You can define whatever tool you like for your use case. In our simple example, let's define 2 functions as 2 tools. Retrieve payment status to retrieve payment status from the data based on transaction ID, and retrieve payment date to retrieve date information. Next, in order for Mistral models to understand these tools, we need to outline the function specs with a JSON schema. Let's list all the tools in the list. For each tool, we need to define the type of the tool. In this case, is a function. The function name. Our first function is retrieve payment status. Description of the function and the parameter of the function. It's also important to define the description of the parameters and also which parameter is required, so that our model can figure out the right value for the required parameter. And then when we do the same function specs for the second function, retrieve payment date, then we can organize these functions into a dictionary. The keys are the function names, and values are the function with the df defined. This allows us to call the function easier in later steps. In addition to the function, users also need to provide a user query. For example, what is the status of my payment? We use this chat message method to format our messages and add it in a list called messages. This is where we store all the messages and give it to the model. The second step is for our model to generate function arguments. In this step, we use the Mistral Python client to call our API. You will need to get the API key from our website. Navigate to API keys, click Create New Key, and you will be able to create an API key. And then we need to define the model, messages, and the tools. The result returns the assistant message. I need the transaction ID to check the status. Could you please provide me with the transaction ID? This is because our function requires a transaction ID. That's why our Mr. Model is asking for it. We add this message to the messages list and add a user message telling the model that my transaction ID is T1001. Now you can see three messages: the user message, the system message, and another user message. Let's run the model again with these messages and the tools we defined. We can see the model returns the information about the tool calls. It tells us the name of the function we should run and the arguments for the function. Again, we add this message to the messages list. Step 3 is for users to execute this function to obtain tool results. Currently, it's up for the users to execute these functions. Let's first extract some useful function information from the previous model response. Let's define the tool calls response as tool call and get the function name and function params. We can see that our Mr. Model has chosen to use the function retrieve payment status with the parameter transaction ID T1001. Now let's execute this function with the function name and function parameter, and we get the result status paid. Let's append this message again to the messages list and passing all the 5 messages to the Mr. Model. And we get the customized final response for this specific user query. The status of your transaction with ID T1001 is paid. So that's it for function calling. Hope you find it helpful. See you next time. Bye.
All right, so that's an overview of what we're going to do next. So, next, let's fine tune your model for function calling. Now we're ready to fine tune our first model for function calling. How do we train our model for function calling? Answer: we need data. A model training process can be divided into 3 steps. Step 1, the model is pre-trained on a large quantity of data. The output of that step is a pre-trained model. For instance, Google slash Gemma-2 2B. It's a base model and only knows how to predict the next token without strong instruction following capabilities. To be useful in a chat context, the model then needs to be fine-tuned to allow instructions. In this step, it can be trained by model creators, the open source community, you, or anyone. For example, Google slash Gemma-2-2B-IT is an instruction-tuned model by the Google team behind the Gemma project. So that IT more than likely stands for instruction-tuned. Number 3, the model can then be aligned to the creator's preferences. For instance, the customer service chat model must never be impolite to customers. Usually a complete product like Gemini or Mistral. Um, we'll go through all three steps, whereas the models you find on Hugging Face have already completed one or more steps of this training. In this tutorial, we will build a function calling model based on Google slash Gemma dash 2 dash 2B dash IT, which we know stands for instruction tuned. We choose the fine-tuned model um, uh, dash IT, instruction tuned, instead of the base model dash 2B, B presumably standing for base, because the fine-tuned model has been improved for our use case. All right, so starting from the pre-trained model would require more training in order to learn instruction following, chat, and function calling. By starting from the instruction tuned model, we minimize the amount of information that our model needs to learn. LoRA, low rank adaptation of large language models. LoRA is a popular and lightweight training technique that significantly reduces the number of trainable parameters. It works by inserting a smaller number of new weights as an adapter into the model to train. This makes training with LoRA much faster, memory efficient, and produces smaller model weights, a few hundred megabytes, which are easier to store and share. So here's LoRA inference. Let's take a look at that bigger. So we've got a lot of crazy things going on here. Um, so we can see there is there's a key here. It looks like it's color coded. Uh, so this is yeah. So now it's restarting. So there we go. What's next? So this process here. What's next? All right, this whole process here, and then this here. Okay, so not sure what that means, but let's keep going. All right, so LoRA works by adding pairs of rank decomposition matrices to transformer layers, typically focusing on linear layers. During training, we will freeze the rest of the model and will only update the weights of those newly added adapters. By doing so, the number of parameters that we need to train drops considerably, as we only need to update the adapter's weights. During inference, the model is passed into the adapter and the base model, or these adapter weights can be merged with the base model, resulting in no additional latency overhead. LoRA is particularly useful for adapting large language models to specific tasks or domains while keeping resource requirements manageable. This helps reduce the memory required to train a model. If you want to learn more about how LoRA works, you should check out this tutorial. Fine-tuning a model for function calling. You can access the tutorial notebook here. Okay, so they want you to, um, yeah, so this is the meat and potatoes of the bonus section, is going through this notebook and doing everything in there. So, okay, yeah, and here's, so this is from the NLP course, low rank adaptation. We already read about that in my other series where I read a book about that. So this would be a great course to do later on. And in fact, I think if I go to my career folder, Hugging Face, courses, yeah, I have this one listed as the next one to do. Let me put a star on that as well, because then it's very clear to me that this is the next one that makes sense to do. Okay, but for now, let's open this in Collab and just do this uh, up in Collab and not worry about doing it locally, um, and just go through and read all this, run all the commands. and then move on. In fact, I'll read the conclusion now, and then we'll go back and work on that later. So conclusion, congratulations on finishing this bonus unit. You've just mastered understanding function calling and how to fine-tune your model to do function calling. If we have one piece of advice now, it's to try to fine-tune different models. The best way to learn is by trying. In the next unit, you're going to learn how to use state-of-the-art frameworks such as Small Agents, LlamaIndex, and LangGraph. Finally, we would love to hear, yeah, so that's just, okay, keep learning and stay awesome. There we go. So now let me click on next unit so we can see unit 2.1 is the next one. So unit 2, now unit 2 does have a little bit of an overview here. Let's read, so I'll save this for another video. But this video, I'm gonna do this notebook here, which might take me a while. Let's see where I'm at. All right, I'm only at the 20-minute mark, so this should be about an hour video. Hopefully this only takes 40 or so minutes. But for now, I gotta take a break. I'll be right back. All right, I'm back. So let's try to get through this notebook. So, bonus unit 1, fine-tuning a model for function calling. In this tutorial, we're going to fine-tune an LLM for function calling. This notebook is part of the Hugging Face Agents course, a free course from beginner to expert, where you'll learn to build agents. All right, so prerequisites before diving into the notebook, you'll need to study what is function calling. Did that. Check that off. Don't see how to check that off. Oh, yeah, so here's how to check that off. I think you could just do, yeah, we'll just do that. Okay, there's probably another way to do it. Yeah, so an emoji. Yeah, I think that would be the way to do it. Okay, so let's try to add an emoji. Oh, you know what? I think this is a... I wish I knew what this actually was. Reposition markdown preview, don't need to do that. I think we could do an emoji. All right, well, we'll just go with the tried and true way. All right, that's fine. Well, but this is a capital X and with the lowercase. There we go. Moving on. So step 0, ask to access Gemma on Hugging Face. So okay, so make sure you're signed into my account. I should be. Go to this link here, click on Acknowledge License, and fill in forms. So there we go. I do want to direct. So now I need to click on Acknowledge License down here. We need to agree to Google's usage policy. Okay, and then we're going to click Authorize. And fill out a form. I'm going to do this off camera in case there's... Yep. All right, I'm back. So I was worried there might be something I wouldn't want to show on camera, but actually I think it's really important to show this on camera. Everyone knows my first and last name by now and my email. That's actually something I want people to know because this channel is about a tech community. So if other people are in this space, that's good that they have that information. So, but this stuff actually needs to be on camera rather than off of camera. These are the gamma terms of use. So I'll just briefly look this over. I'm not going to read this whole thing out loud, even though I probably should. But you know what? We live in the modern world, so let's put this whole thing into the LLM and say what's the most important thing to know about this. And we can use voice mode. So, what is the most important thing to know about these terms of use? Okay, ask it that, and let's see what we got. Okay, so the key takeaway is you're agreeing to a legally binding set of rules. You must follow strict usage and distribution guidelines, including proper notices if you manage to modify or share the service. You're solely responsible for any outputs you generate. Okay, so it's kind of a cover CYA, cover your A, and you accept that the service is provided as is with no warranties, meaning if it breaks your system, you can't hold Google to account. Tell me more about the strict usage and distribution guidelines. And I got one more. Is this a fairly standard terms of summary, or does anything stick out as surprising? All right, so let's see. So redistribution, inclusion of restrictions. Okay. Notice text. Okay, so you have to like credit them. You have to make it clear that you're using a modified version. So they have the right to restrict or even remotely disable your access. So overall, the terms follow a fairly standard legal structure, but a few elements are particularly notable. Strict redistribution requirements. You must include the original requirements and notices. Um, so this is a level of control that isn't always seen in more permissive open source licenses. So this is a little bit more restrictive than usual. Clear marking of modifications. This is unusual as well. You have to make sure you maintain transparency about what has been altered. Output ownership. Yeah. Yeah, you're on your own if things go wrong. I mean, that shouldn't be a surprise. Yeah, this shouldn't be. I guess if you're used to static licensing models, being cut off from the API the moment uh, you breach, you're suspected of breaching the terms, could be pretty jarring. So you got to expect that. It is important to do your best to follow these terms, especially if you're using something like an API service, because they can just cut off your access to the service. Okay, so the last question I have for you about this is like, it seems like this is pretty high stakes because if you're using like an API service for this model, they can just straight up like cut your service off, right? If they perceive that you are violating the terms. But what if like there's a dispute and like you don't think you're violating the terms and you think they're just like cutting you off because perhaps you're using the model in a way that like competes with some of their interests, and even though you're not violating their terms in any way, they just cut you off as part of like monopolistic power. Like, is that a situation that can happen, and like is there any recourse for that situation where you can like get your access back or like dispute it or something like that? Yeah, I think this is a good question because, yeah, this is a very real risk. So this is another argument for building versus buying. I'm sure it's not often that they do this, but you probably do need some sort of backup solution in mind in case this happens. You can use another service, switch to another service pretty easily, prepare to do that. And this is another good argument for you doing things locally, building rather than buying. All right, moving on. Yeah, so you can like take them to court, but it's set up so that they'll win. So you're very unlikely to win. I mean, this is the disadvantage of buying versus building. One of the disadvantages. All right, so but looks good to me, so I'll accept that. I don't want spam. And yep, so alternatively, you can use another model and modify the code accordingly. It can be a good exercise for you to know how to fine tune for function calling. You can use, for instance, these other two models. We're not going to do that. So step one, if you're on Colab, to accelerate the fine-tuning training, we'll use a GPU. To do that, go to runtime, change runtime type. Okay, there we go, and we'll use a GPU. So the only one I have available is a T4 GPU, so let's use that. All right, important. In this unit, with the free tier of Collab, it'll take about 6 hours to train. You have three solutions if you want to make it faster. Train on your computer if you have GPUs. This might take less time, but you have less risk of timeout. Use a Google Colab Pro that allows you to use an A1000 GPU. Um, or just follow the code to learn how to do it without the training. So let's have another conversation with the AI and let's see. Okay, so we're gonna copy selection, paste that in, and then we're going to say, so this, okay, so this notebook uses a T4 GPU. Locally, I have an RTX 2060. If I were to run this locally, uh, what would happen? What can I expect for that 6 hour training time? Would the training time be faster or slower on my RTX 2060? All right, and let's do a Google search for this T4 GPU, try to figure out more about that. So this is an NVIDIA T4 Sensor Core for GPU for AI inference. So it's probably quite a bit more sophisticated than the one I got. Let's put it into TechCrunch. All right, and Control F is not working. Oh, there we go. T4, nothing. So yeah, I want to let me just yeah, we were going to search. Yep. So T4. Ah, there you go. So now, so yep, this is a Tesla T4. Here's the data sheet. Yeah, NVIDIA T4, um, which is the same thing as a Tesla T4. So we should be able to see. Oh no, it's a Turing, NVIDIA Turing. Um, well, I think it's this one. So the GPU chip is a TU104. That should be the same. That should be listed on here somewhere. TU104. Oh, okay. There is no. Well, that's too bad. I can't tell what this actually is. Um, yeah, I can't tell. Yeah, it says it's an NVIDIA Turing, but I don't see an NVIDIA Turing, so I can't tell what this actually is. So let's look at Google. Yeah, you know what? I think it's a Tesla. These other ones have say Tesla, and it looks like the same form factor. So not a foolproof uh, confirmation, but close enough. So let's select the Tesla T4. Yep, I think this is definitely it. So yeah, we can see memory is way bigger than my 2060. I'm going to scroll up to find my 2060 because that's probably where it is. I have an RTX, not a GTX. I have a yeah. So here's an RTX 3080. Uh, okay. So actually, my 2060 is a little bit on par. It's 86% the power of the T4, which is not too far off. But you know, unfortunately, that means that that 6 hour figure is going to be it's going to take the full 6 hours. So times it by one, it's going to take one uh, uh, quantity of those 6 hours, and then additionally, it's going to take 14% longer as well. So times that by 1.14. Um, yeah, it's not bad. It should take about 7 hours, where the other one took 6 hours. So for like a big project, it's not the worst thing ever. Yeah, and we can see that's what the AI got as well. It'll likely be slower. It'll likely take about 7 to 8 hours. Yeah, um, so it came up with the AI came up with the same answer that I did. Better off using that T4, but my best option is probably to just skip running the code and just read it instead, because it's going to take my best option right now is 6 hours. Now I do have another GPU. I have a Asus. But it's not actually an Asus. Let's see what it is. I'm pretty sure it's yeah. So I have a GTX 760 as well. But I think the GTX 760 is a far worse option. Yeah. So now the GTX 760, that's only 29% the performance. So it's not nothing. Like I could run a simple model to do simple things on that, like organizing my pictures and videos if I or something like that. But for this, my best option is free T4. So I'm probably going to have to go with option 3. Just follow the code and learn how to do it without actually running the examples. All right, so step 2 is to install the dependencies. We need multiple libraries, bits and bytes for quantization, PEFT for LoRa adapters, transformers for loading the model, datasets for loading and using fine-tuning dataset, TRL for the trainer class. So this one I can definitely run. It was not authorized by Google, so there could have viruses in it. Let's run it anyway. All right, and then step 3, create your Hugging Face token to push your model to the hub. To be able to share your model with the community, here are some more steps to follow. So create an account, did that. Sign in, and then store your authentication token from the Hugging Face website. Yeah, so be very careful not to share it with others. So this is where, you know what? I'm not even going to run the code anyway. So I think I'm just not going to deal with this because I'm at risk of sharing my token, which means others can come in and write bad messages impersonating me, pretending it comes from me. And I can't run it anyway without waiting for 6 hours, so I'm just going to skip that. All right, step 4 would be to import the libraries. But we can't do step 4 unless I put my token here, which is annoying. I'm going to pause. Well, and this is still going too. Well, anyway, moving on to step 5. Processing the data set into inputs. In order to train the model, we need to format the inputs into what we want the model to learn. For this tutorial, I enhanced a popular data set for function calling, Nous Research / Hermes function calling v1, by adding some new thinking step computer from DeepSeek-AI, DeepSeek-R1-Distill-Quen-32b. But in order for the model to learn, we need to format the conversation correctly. If you followed Unit 1, you know that going from a list of messages to a prompt is handled by the chat template or the default chat template of Gamma-2-2b does not contain tool calls. So we will need to modify it. This is the role of our preprocess function to go from a list of messages to a prompt that the model can understand. So this I could probably run, but I have to go through this step of putting in my key, which is a bit contentious. I'd have to be careful not to scroll up and show that key. So you know what I can do is I can import, I can probably import getPass from getPass, import getPass, and then do like HF token equals yeah, getPass, and we'll do this kind of down here. Okay, and then we'll just have this equals that there. And then if I run this function now, maybe this will work, that I can keep that hidden off camera. So we can see what line it's on now. There we go, going down. And once it gets here, it should pause, and I should be able to pass in the token without it remaining up on here. And off camera, I can grab my token and put it in. But you can see it's got, yeah, so now see how it's paused here? So now it's asking for my token. So let's just put in a fake token. We're going to do 1, 2, 3, 4. Let's put in a token as 1, 2, 3, 1, 2, 3. So I think my keyboard sometimes doesn't work. Yeah, my keyboard stopped working. Ah, there we go. Now it's typing. So let's do 1, 2, 3. Yeah, and see how that's hidden now. So this should be fine if I hit enter. Now nowhere does it show that. So even if we show hide out show yeah, this is already the output. So this should work. I'm gonna do this off camera and get this to work. So I'll be back. All right, I'm back. So that worked really well. One thing I recommend doing is there's really no limit to how many tokens you can create. So if you're doing something like this, or whatever, just create a new token, and then when you're done, delete the token. Because then if it leaks out, as it might do, another good thing to do is it's in my clipboard right now, so I'll copy something else into my clipboard so I don't accidentally paste it out. But yeah, be really careful with the tokens, and create a token for each thing you're doing with a token. That way, when you're done using the token, you can delete the token, and not just have like an extra token sitting out there ready for somebody to use, especially for write tokens. If you ever create a write token, um, immediately when you're done using whatever you're using it for, delete the write token. All right, so step 5 is processing the data set into inputs. In order to train the model, we need to format the inputs into what we want the model to learn. For this tutorial, I enhanced a popular data set. Yeah, so we read all of this. Well, actually, I don't really remember reading this. So I enhanced a popular data set. Yep, there we go. By adding some new thinking step computer from that model. But in order for the model to learn, we need to format the conversation correctly. If you followed Unit 1, you know that going from a list of messages to a prompt is handled by the chat template, or the default chat template of gamma-2-2b does not contain called tool calls. So we will need to modify it. This is the role of our preprocess function to go from a list of messages to a prompt that the model can understand. So there we go. Looks good. So I'll run this, and hopefully it doesn't immediately show my token. Yep, so we're going to grant access to that, and it's not going to show me any specifics about that, hopefully, not even down here. Um, all right, as far as I know, it did not, but best practice is uh, oh, but not utilizing the GPU? What? What does that mean? That was an odd message. Anyway, moving on. This looks like this ran successfully in 13 seconds, so I guess that's all I need to know for now. There might be issues later, but basically where I want to get it is to run those 6 hours, and just as it's doing that, just end the video. Maybe leave it to run, but probably just move on. All right, step 6, a dedicated data set for this unit. For this bonus unit, we created a custom data set based on that the parent data set. We created a child data set off of that data set, the custom for this unit, which is considered a reference when it comes to function calling data sets. While the original data set is excellent, it does not include a thinking step. In function calling, such a step is optional, but recent work like DeepSeek Model or the paper Test Time Compute suggests that giving an LLM time to think before it answers, or in this case before taking an action, can significantly improve model performance. I decided to then compute a subset of this dataset and give it to DeepSeek-AI, DeepSeek-R1-Distill-Quen-32b in order to compute some thinking tokens, think before any function call, which resulted in the following dataset. All right, so there's a special data set. Let's take a look at this. So the data set looks like it's got content there. Yeah, okay. So let's run this. And there we go, it's working. So it's completed in under a second. And now we've got that new data set. So step 7, checking the input. Let's manually look at what an input looks like. In this example, we have number 1, a user message containing the necessary information with the list of available tools in between those tags. Then the user query. Here, can you get me the latest news headlines for, oh God, the United States? Um, an assistant message here called model to fit the criterias from Gamma models containing 2 new phases, a thinking phase contained in those tags. They kind of look like HTML tags or XML tags. So the tag is just like any other tag of that sort, open and close chevron, so less than sign, then think, then greater than sign, and then less than sign slash think, greater than sign to indicate that the tag is enclosed, is ended. And then act phase contained in the tool call tag, similar to the think tag. If the model contains a tools call tag, we will append the result of this action in a new tool message containing a tool response tag with the answer from the tool. Let's look at how we formatted the data set. All right. All right, and here's our sanity check. So sanity check presumably passed because we've got, yeah, and see what it's doing? It's getting those tokens, right? Because the special characters are different for every model. So, yeah, I think that's what we're doing here. Like these EOS. So now we're doing a sanity check. What's the pad token? There we go. What's the EOS token? So it's going to be different from model to model. So we're doing a sanity check to make sure we've got the right special characters for this model, and we do. Which, I mean, it's kind of an odd sanity check because I don't see where we would compare it against. I don't see how we know that these tokens are the correct tokens for the model. Like I see it's printing out the token, but I don't see that it's confirming that the token is correct. Anyway, step 8, let's modify the tokenizer. Indeed, as we saw in Unit 1, the tokenizer splits text into subwords by default. This is not what we want for our new special tokens. While we segmented our example using think tool call and tool response, the tokenizer does not yet treat them as whole tokens. It still tries to break them down into smaller pieces. To ensure the model correctly interprets our new format, we must add these tokens to our tokenizer. Additionally, since we changed the chat template in our preprocess function to format conversations as messages within a prompt, we also need to modify the chat template in the tokenizer to reflect these changes. So let's do that. We're going to modify the chat template in the tokenizer to reflect those changes. Looks like it takes a while to do that. This .safe tensors deals with 5 gigs of information that needs to be downloaded. And this isn't my connection since it's running from a Colab. It's a connection from Colab to there. So my connection is quite fast, but it looks like that connection is quite slow. Yeah, I have well, today it's not so fast, but typically it's 600 up and down. So, ooh, and my up is very, very bad. Um, I don't know what's going on with that. Why is it so bad? But this is going to take about an extra minute. All right, so moving on to step 9. Let's configure the LoRa. This is we are going to define the parameter of our adapter. So they're missing a word, where, I think. So to say this is where we are going to define the parameter of our adapter. those A, and I think that should say those are, ARE, those are the most important parameters in LoRa as they define the size and importance of the adapters we are training. All right, so this is kind of, I'm not sure if they expect people to get this far because the editing kind of leaves a little bit to be desired. All right, now I'm running, wow, it's as if I went back to my old provider. Hey, but my upload's great. Well, anyways, yeah, so we just gotta wait and run this next. So, but let's read step 10. Step 10, let's divide the trainer and the fine-tuning hyperparameters. In this step, we define the trainer, the class that we use to fine-tune our model, and the hyperparameters. And we see another typo there, so lots of typos. We do need to modify the code here, so let's do that as that's running. We'll get my username, which is right there. Okay, and then there we go. We've got a long comment here that okay, so we can leave that the way it is. Then nothing else needs to be modified. So this looks like it's about to wrap up. It's on to the next files, the next steps. Yeah, so now it's done. Really cool, you can see which line it's working on. We can see it's finished. So let's take a look at this next one. Oh, this one just works quickly. Maybe this one will take a while. That one works quickly as well. So here's the next one. As trainer, we use the SFT trainer, which is a supervised fine-tuning trainer. All right, so now we see this little arrow here pointing to the right in green. That's shows the line of code that is running as it's working, and then the stop sign here shows that it's executing and that you have the option to interrupt the execution. So here we launch the training. Perfect time for you to pause and grab a coffee. So this is going to take 6 hours here, but it looks like the tutorial is nearly complete, so should be fine. But we can see this completed in 29 seconds. This is going to take a bit longer than that. It's going to take about 6 hours. So I will take a break. I'll come back and I'll just read the rest of the notebook. We probably won't be able to run the code, but it'll be, I'll end the video and I'll be ready for Unit 2. So I'll be right back. All right, I'm back. So this cell is going to take a full 6 hours. We can see the estimated time is 6.5 hours. So, and we remember this from like other videos I've done. The training is going to happen in epochs. So it's yeah, this looks familiar from other videos. But anyways, I'll just read out everything. I might end up canceling this, and I'll be ready for Unit 2, even though this training hasn't completed successfully, and the other code hasn't run as a result. So step 11, let's push the model and the tokenizer to the hub. Let's push our model and our tokenizer and out, OUT, so this has editing issues, to the hub. The model will be pushed under your username plus the output directory that we specified earlier. So we specified the output directory here. I think this is, yeah, a fine output directory. Okay, and I'll have to wait. You know what? I might just do this in the morning tomorrow, because it would be nice to have this up like as a part of. Because the other thing, you know, Hugging Face is a one-stop shop. It's also a one-stop shop for like hiring and finding jobs, because you're going to have a output directory on your account that shows the projects that you've done. So if you can get some really sophisticated projects up there, you can show that you can link them to portfolios. So for example, my first agent template, I can send an employer an example of the project I made, and we can talk about that like in the screening call or in the interview. Um, and we can talk about all the files and all the modifications I made. So Hugging Face is a one-stop shop for everything, including hosting your projects that you can talk about when it comes to getting a job. All right, so there we go. So that this would end up in your projects. Since we also modified the chat template, which is contained in the tokenizer, let's also push the tokenizer with the model. All right. And then step 12, let's now test our model. To do so, we will load the adapter from the hub, load the base model from the hub, resize the model to with the new tokens we introduced. So typo there. Um, and then print out the data set. Okay, so now testing the model. Oh, okay, this is a new one. Okay, so my drink did not spill, thankfully. That typically happens. Um, okay, yeah, so my drink didn't spill, so okay, that is good. What happened was my book holder, I have a giant book holder for reading big books. I'm reading a cookbook on it right now, but it gave out and the book fell, and it did knock over my drink, but I drink out of a sippy cup. Okay, there we go. So, okay, testing the model. So in that case, we will take the start of one of the samples in the test set and hope that it will generate the expected output. Since we want to test the function calling capabilities of our newly fine-tuned model, the output will be a user message with the available tools. So here's a disclaimer. The data set we're using does not contain sufficient training data and is purely for educational purposes. As a result, your trained model's outputs may differ from the examples shown in this course. Don't be discouraged if your results vary. Our primary goal here is to illustrate the core concepts rather than produce a fully optimized or production-ready model. So congratulations on finishing this first bonus unit. You've just mastered what function calling is and how to fine-tune your model to do function calling. If it's the first time you do this, it's normal that you're feeling puzzled. Take time to check the documentation and understand each part of the code and why we did it this way. And don't hesitate to try to fine-tune different models. The best way to learn is by trying, so keep learning and stay awesome. All right, so that brings me back to the training cell, the training code. So it's going to be on this trainer.train for another 6 hours and 45 minutes. And I'll just leave it there. And in the meantime, I'll like read from the Kindle book or like maybe work ahead to, or maybe start unit 2. But this is it for unit 1 and the bonus unit. There's nothing else to do for that. And I'm ready for unit 2. Although I will come back to this probably tomorrow morning, maybe make another video out of getting through that. But for now, stay tuned for unit 2.